You are listening to The Vocal Technologist. Spoken tech for your ears.
Imagine a scenario that sounds completely absurd but is entirely factual. Picture a world where your company credit card is controlled by an autonomous AI agent settling transactions in fractions of a penny.
Yeah, and while that is happening in a laboratory somewhere, a literal dish of human brain cells is just, well, busy playing a retro video game.
Which sounds like pure science fiction, right? But it is the actual reality that researchers and engineers are building right now.
It really is. We are watching the rigid boundaries between digital systems, financial economies, and organic biology just completely break down.
That is exactly what we are here to pull apart. If you are a curious professional who wants to understand where technology is actually heading without having to sift through endless reports, you are in the right place.
Spot on. We need to look under the hood of the AI coding Cold War, explore the mechanics of these new, non-human autonomous economies, and really get into the wildly fascinating evolution of biological computing.
Because the societal implications of these seemingly disconnected events are massive. When you synthesize them, you realize we are fundamentally reorganizing how work, value, and intelligence function across the board.
Exactly. It is not just about faster computers. It is about, redefining what a computer even is.
Okay, let us start with the human element, because there is this intense existential dread floating around the tech sector. Everyone is asking if AI is actually replacing essential jobs or if it is simply automating performative office tasks.
Right. The illusion of work.
Yeah, exactly. I mean, have you ever sat in a meeting that absolutely could have been an email? Or spent an enormous amount of effort building a slide deck that nobody actually looked at?
Oh, absolutely. We all have.
Right. So there is a strong argument that a huge amount of modern work is hollow. We engage in a performative productivity that everyone silently pretends is real. So when we see mass layoffs, are they really about an immediate AI takeover?
Or is it more about the fact that those jobs were already obsolete? That is a very sobering perspective. But if you look at the economics of the tech industry, it is pretty accurate. We tend to conflate the arrival of a new technology with root cause of job loss. But in many cases, the underlying vulnerability in those roles existed long before the algorithms became sophisticated.
So it is just exposing the bloat.
Exactly. During periods of massive economic growth, companies inflate their headcounts. AI is simply the catalyst, forcing organizations to confront that bloat. And the race to build the tools that expose this bloat is incredibly fierce.
It is fierce, and it is also surprisingly personal. You look at the feud between the executives at Anthropic and OpenAI, they have fundamentally different philosophies on how artificial intelligence should be created.
Yeah, Anthropic pushes heavily on alignment and safety, while OpenAI has historically pushed for rapid deployment.
Right, and they are battling it out in the market right in front of us. Anthropic achieved some staggering revenue milestones with Claude Code. They rapidly crossed $1 billion in recurring revenue in a staggeringly short window.
Wow.
I know, right? And then they hit $2.5 billion. They completely surpassed Cursor, which everyone in the development community thought was completely unstoppable.
Which really highlights how perceived momentum can evaporate overnight in this industry. Cursor was the absolute darling of the coding world.
Yeah, the tool every developer felt they had to use.
Exactly. Suddenly they are outpaced by Anthropic. But they're not just giving up. Cursor is pivoting hard. They are building a research powerhouse specifically to outmaneuver Anthropic and OpenAI.
And focusing on enterprise clients, right?
Spot on. They are prioritizing contracts with large corporate clients. Because if you secure a massive enterprise contract, that is far more stable than relying on fickle consumer subscriptions where developers just jump ship the moment a slightly better tool emerges.
But look, let us pause and do a reality check here. If you are listening to this and worrying about your job, take a breath. The tech is absolutely not perfect yet.
Not at all.
Over at Amazon, their internal AI tool called Kiro is actually slowing developers down. It constantly hallucinates flawed code. I mean, if an AI writes 10 lines of code but hides a subtle logic error in line 7, a human engineer might spend a massive chunk of their workflow hunting for that mistake.
Which completely erases any time they saved.
Exactly. Meta also had to delay their avocado foundational model because it failed their internal tests for abstract reasoning and coding. Apparently, it just could not compete with rivals, so they held it back and are already moving on to their next model.
Creatively named watermelon.
Naturally. So I have to ask you directly, is the tech industry just full of people looking busy while holding a clipboard on a construction site? Like, is AI actually replacing software engineers or just exposing the clipboard holders?
It is primarily exposing the clipboard holders, without a doubt. The core engineering work, the complex logic, and system design is still highly reliant on human cognition.
Because of the abstract reasoning.
Right. When tools like Kiro or Avocado fail at reasoning, it proves that abstract thought remains a uniquely human premium. AI is brilliant at pattern matching and syntax, but it struggles with the overarching architecture of a system.
So the engineers are not disappearing.
No, but their daily workflow is being radically redefined. They have to focus purely on high-level problem solving rather than rote typing.
Which brings the listener right into the crosshairs of how developers are using these imperfect tools to bypass human rules altogether. This is where it gets properly weird.
The licensing workaround.
Yeah. A developer had a disagreement over a general public license, or GPL, on an open source project. For those who do not know, a GPL basically says if you use this code, you have to share your own code.
Right.
So this developer just used AI to generate a complete clean room implementation of the entire project from start to finish.
And to understand why that matters, we really have to explain the mechanics of a clean room implementation. Historically, if you wanted to copy a piece of software without violating copyright, you had to hire two separate teams.
Which is incredibly expensive.
Hugely expensive. Team A would look at the original software and write a manual describing exactly what it does. Team B, who has never seen the original code, would read that manual and write brand new code to match the functions.
But now you just feed the parameters into an AI and it does the job of Team B in seconds. The results in this specific case had only 1.3% common code with the original project.
Wow, only 1.3%?
Yeah. People are saying this signals the death of copyleft agreements because companies will gladly spend heaps of computing budget having an AI rewrite a project rather than dealing with the headaches of legal licensing.
It is a massive shift in how we handle intellectual property.
But I am genuinely skeptical about this copyright loophole. I mean, if an AI rewrites a locked door to look, slightly different, is it really a new door or is it just a very fast lockpick?
I actually really like the lockpick analogy, but legally, it is slightly different. Copyright does not protect the functional idea of the door itself. It protects the specific paint job, the carvings, the exact expression of that door.
Right.
The AI is changing the expression just enough to evade the literal text of the law, even if it feels like it violates the spirit of the open source community. It is forcing the legal system to figure out what we're actually trying to protect.
Yeah.
Are we protecting the human effort or the underlying utility of the software?
And while the lawyers argue over doors and paint jobs, developers are coming up with new ways to constrain the AI itself. Because right now, AI is basically just a highly educated guesser, right?
Mostly yes. It looks at a line of code and guesses what the next word should be based on probabilities.
But if you are building software to run a power grid or, well, a hospital system, you do not want guesses. That is why there is a new coding system called Don't Vibe Prove.
Yes, and the mechanics behind Don't Vibe Prove are fascinating. We are moving from probabilistic generation to deterministic verification.
Which sounds complicated, but what does it actually do?
It forces the compiler to entirely reject the generated code until a mathematical proof satisfies the type specifications. The system actually has to mathematically prove to the compiler that the logic is flawless before the code is allowed to execute.
So it stops the AI from just vibrating its way through an assignment based on what looks correct.
Exactly. It forces it to prove mathematically that the output actually works.
Which means developers are getting unprecedented access to build these highly reliable systems. Take Perplexity. They have launched a full-stack, model-agnostic API.
And model agnostic is the key phrase there.
Right. It means developers are not locked into one company. You can literally hot swap between the best frontier models on the fly.
Right.
More importantly, it gives those autonomous agents direct access to real-time indexes and citations.
Which is huge for accuracy.
Huge. You can build agents that pull factual, cited information rather than just relying on historical training data.
But this raises a massive logistical question. If you have an autonomous agent negotiating API calls, purchasing computing power, or buying data snippets on behalf of a user millions of times a day, traditional payment rails are simply going to break.
Oh, of course. Our financial system is not built for machines.
Right.
Let us say your AI agent needs to read a research paper behind a paywall, and the access fee is 1/10 of a single cent. If it tries to use a regular company credit card, the network fee alone would mathematically fail the transaction. The fee costs way more than the product.
Precisely. That is why financial giants like Circle and Stripe are building stablecoin blockchains specifically for this machine economy.
Okay, so how does that work?
Well, Circle has a blockchain called Arc, and Stripe has one called Tempo, which already has a $5 billion valuation. Blockchains use smart contracts that execute in absolute fractions of a moment without a middleman taking a massive cut.
Right. So these ledgers allow AI agents to make millions of microtransactions at fractions of a penny. But hang on, stablecoins are basically digital cash. If an AI agent gets scammed or makes a mistake, that digital cash is just gone. There is no customer service line to call to reverse a blockchain transaction.
That is the big risk. They completely lack the fraud protection and dispute resolution of traditional credit cards.
So the solution they are exploring is virtual cards. They issue a traditional virtual credit card number to the AI, but it settles via stablecoins on the back end.
That is clever.
It is. It is merging the microscopic cost of crypto with the consumer protections of Visa or MasterCard.
It is an entirely non-human financial ecosystem operating just beneath the surface of our own. They are literally building the financial plumbing for machines to pay other machines.
Okay, so we have non-human economies and AI agents rewriting software. But all of these digital systems are hitting a massive physical wall. They are hitting performance bottlenecks in traditional silicon.
Right, because the server farms require entire power plants just to keep them cool.
Exactly. So scientists are doing something that sounds, frankly, absolutely unhinged. They are turning to actual biology to compute data.
Yeah, the wetware research.
I am looking at research detailing how 200,000 living human neurons grown on a microelectrode array were taught to play the video game Doom.
It is a phenomenal leap. And to understand why they are doing it, you really have to look at energy efficiency. Silicon-based neural networks are incredibly power hungry.
Right?
The human brain, however, runs on about 20 watts of power. It is a marvel of biological efficiency. So researchers place living neurons onto a chip that can send and receive electrical signals. They feed the game state of Doom into the neurons as electrical pulses.
I have to admit, I find this both amazing and deeply horrifying. Like, how does a brain cell even know it is playing a video game?
It doesn't know it is playing a game. It only understands electrical feedback. When the neurons successfully navigate the game environment, the system provides a predictable, orderly electrical pulse. Biological systems crave predictability. When the in-game character takes damage, the system blasts the neurons with chaotic, unpredictable, white static.
Oh, wow.
Through reinforcement learning, the neurons literally physically rewire their own connections to avoid the chaotic static and seek the orderly pulse. They learn to play the game simply to achieve electrical equilibrium.
It is basically the Matrix, but instead of using us as batteries, they are just making our brain cells play retro shooters.
Yeah.
Which, yeah, is exactly as terrifying as it sounds.
It definitely evokes a certain dystopian imagery,
Yeah.
but the practical applications are profound. We are looking at a future where biological wetware could handle complex pattern recognition tasks at a fraction of the energy cost of current silicon processors.
We are escaping the limitations of manufactured chips by harnessing eons of biological evolution.
Exactly.
And it is not just biological hardware. We are also realizing that to train better physical systems, we need massive amounts of real-world interaction. Look at Sunday Robotics.
They have a very unique approach.
They do. They secured major funding for a fascinating approach to building home robots. They use zero robot data.
Zero.
None. Instead, human data collectors wear hats with wide field of view cameras and special gloves. They operate exact duplicates of the robot tools to gather massive amounts of real-world data.
This highlights a crucial limitation in our current technology. You can simulate physics in a digital environment all you want. You can teach an AI the mathematical concept of gravity or friction.
But the real world is messy.
Incredibly messy. A digital simulation does not fully capture the flexibility of a crumpled towel or how unexpected lighting changes the shadow on a staircase. By having humans perform the tasks physically, Sunday Robotics captures high-fidelity data of actual human tactile response.
They're bridging the gap between digital simulation and physical reality. It is like we have to physically hold the hand of the machine and show it how to exist in our world.
That is a great way to put it.
And even back in Cure software, we are using autonomous systems to do the heavy lifting of optimizing our existing infrastructure. Shopify used an incredible system called auto research.
Right, the optimization engine?
Yeah, they ran hundreds of semi-autonomous experiments to find micro-optimizations in their legacy liquid template engine. They made it 53% faster with 61% fewer memory allocations.
And that ties perfectly back to what we discussed earlier regarding the role of the human engineer. The AI is not necessarily writing the grand architecture of Shopify from scratch,
Right.
but it is an unparalleled tool for iterative optimization. Finding a 53% performance increase in a mature code base is nearly impossible for a human team to do efficiently. A human engineer would get bored testing tiny variations.
The machine simply has the infinite patience to test tens of thousands of micro-variations until it finds the mathematically optimal path.
Exactly.
So AI is optimizing our code, and human brain cells are playing video games.
But you and I, and everyone listening, we still live in the physical world. We cannot live inside a server, thankfully.
Yeah. While software figures out its own identity crisis, we are seeing hardware, medical science, and space exploration achieve things that code simply cannot touch. Let us look at Apple.
They're making some very interesting moves.
They have a deliberate strategy to expand their ultra and super premium tiers across the iPad and iMac lines. We're talking about the development of a foldable iPhone and an OLED MacBook Pro.
Right.
And they added two new designers, Steve Lemay and Molly Anderson, to their executive leadership page, which signals a massive turning point for their hardware focus.
Apple understands a fundamental economic shift. As software becomes increasingly commoditized by generative AI, the physical object becomes the primary differentiator.
Because the software is basically the same everywhere.
Think about it. If every single device, regardless of the brand, has access to an omniscient digital assistant, the software is no longer the selling point. The consumer decision relies entirely on the tactile experience, the build quality, the weight of the metal, and the status symbol of the hardware itself. Apple is doubling down on the physical experience because that is what AI cannot replicate.
Which leads me to a pointed question. With the broader economy often feeling uncertain, and tech jobs shifting the way we unpacked earlier, why is Apple deliberately pushing towards a super premium hardware tier?
It seems counterintuitive, right?
Totally. Are they banking on an entirely new class of consumer who can just afford to drop thousands of dollars on a foldable phone?
They are banking on the bifurcation of the market. They recognize that the middle market is hollowing out. Moving forward, consumers will generally do one of two things.
Which are?
They will either seek the absolute cheapest functional device that runs the AI software, or they will invest heavily in ultra-premium durable goods that offer a flawless physical experience. Apple is firmly planting its flag in that upper tier.
That makes a lot of sense. You pay for what you can hold. They are using the brilliance of designers like Lemay and Anderson to ensure their hardware justifies a premium price tag in a world where software is effectively cheap.
Exactly.
And speaking of manipulating the physical world, medical science is making leaps that sound like absolute miracles. Over in Japan, Sumitomo Pharma received a world-first approval for Amchepry.
This is incredible research.
It is a treatment that takes lab-grown stem cells, develops them into dopamine precursors, and transplants them directly into the brains of Parkinson's disease patients.
Wow.
And the medical startup Currips got approval for ReHeart, which uses actual heart muscle sheets to help form new blood vessels and restore heart function.
These are monumental medical milestones because they represent a fundamental change in how we treat disease. For decades, medicine has largely focused on managing symptoms with maintenance chemicals.
You take a pill to artificially boost a chemical level?
Right. But transplanting lab-grown stem cells to restore natural dopamine production is a structural fix. We are moving from chemical management to physically repairing and replacing broken biological infrastructure.
It is a profound manipulation of the physical world at a cellular level, entirely distinct from anything an algorithm can do on a screen.
It absolutely is.
And if you want to talk about manipulating the physical world on a massive, almost incomprehensible scale, look at space exploration. The Double Asteroid Redirection Test, or DART mission, literally crashed a vending machine-sized probe into an asteroid at an immense velocity.
And the mechanics of that impact are what make it so impressive. It was not just the kinetic force of the probe itself.
Right.
The initial impact created a massive plume of rock and dust ejecting into space. That ejecta acted like a thruster, providing a massive secondary push against the asteroid.
Which is brilliant.
That combined force successfully altered the trajectory and velocity of the entire Didymos binary system.
We are literally moving celestial bodies and changing orbital paths around the sun. We can move asteroids, but we still complain when the wireless internet drops out.
It really puts our struggles with writing reliable code into perspective. The DART mission is a triumph of classical physics and kinetic engineering.
It reminds us that while we spend so much time obsessing over digital agents and virtual economies, our capacity to engineer solutions in the macroscopic, physical universe remains our ultimate capability. We altered the mechanics of the solar system using math, metal, and velocity.
We really did.
Which brings us full circle. Technology is advancing in every direction at once. The digital world is getting so smart, it is exposing our busy work, while the physical world is demanding bolder engineering to cure diseases and move asteroids.
It is a profound shift in human capability.
It really is. Ultimately, it leaves you with a deeply personal question. If machines are slowly learning to do all of our performative, hollow work, what exactly are you going to do with all your newfound freedom?
That is something we all need to figure out.
Too right. Take some time to mull that over before we explore more of the future together here on Vocal Technologist. Stay curious.
Spoken Tech for your ears.